Hello, everyone. Give everyone a minute or so to get ready. But I want to start off by welcoming you all to our Splinter session on increasing access to astronomical data through sound. My name is Scott Fleming. I'm one of the co-organizers of the Splinter, along with Kate Meredith at Glass Education, who you'll be hearing from shortly. And I want to also give a special thanks to Claire Brasseur and Jen Kotler, who are Astronify team members of mine, also at the MAST archive, who are helping to run the show. And an extra special thanks to some of our speakers who are joining us very, very early in the morning in Australia, very, very late in Europe. So special thanks for going above and beyond to really participate. Next slide, please, Claire. Or Kate, sorry.
Okay, hold on. It's not going. Okay, there we go.
So real quick, run down the agenda, what we're going to be doing today. First, in a few minutes, Kate will be giving a brief introduction on what sonification is and why we all think it's important to increase a sort of access and use of in day-to-day, month-to-month, and year-to-year as we go about our jobs in astronomy, whether you're blind and low vision or not, or otherwise. And then we're going to have a presentation from Anita Zanella, and Chris Harrison, who will be presenting sort of an overview of all the different projects that we're aware of working on sonification. Then we've invited 6 different teams to give very short 5-minute lightning style presentations on their work on sonification, who they are, what their project is about, who it's for. And at the very end, the most important is the last slide, where we ask each of these 6 teams to go off and by themselves independently and come back with the 3 most impactful actions they think we can do as a community to try to increase access to sonified data in the next 12 months specifically. And then the last part of our discussion, Splinter, is going to be where the fun begins. We're going to try and make this interactive and go about by sort of seeding the discussion with those ideas that these 6 teams brought to the meeting. And Jen Kotler will be organizing us through some sort of like conversation and almost like a bubble sorting activity where we try to work together to figure out of all these really good and impactful ideas, which 3 are particularly good takeaways for us to take away from this meeting and really try to make some progress on as a group and as individuals over the next 12 months for sonification. Last slide, please. So the most important part of this slide is just to make sure that everyone joins our Slack channel for the Splinter. If you're not already in the Slack channel, you can find it by going to the very, very top part of the Slack application and just type in the word Splinter_increasing, and you'll find our Splinter channel in Slack, in the AAS Slack space. We're going to be using the Slack channel to do polling. So when we get to the interactive part, we're going to try and use Slack polls as a way for all of us in the Splinter meeting to sort of say whether we think different actions that are presented by the different groups and by you, the audience, are sort of ranked from different impact levels. We're also going to use that to handle a lot of our questions, and also pinned is a lot of good stuff, including a compilation of all the different sonification projects we're aware of in a PDF format, links for ways to join our sonification world chat, which is something that Kate runs outside the meeting every month. It's an international meeting for people interested in collaborating, networking, and working on sonification. So make sure you're at that Slack channel for the next hour and a half at least. And I'll be monitoring it, and we'll also be doing some polling. If you do need or really want to speak through the Zoom, however, we do have our tech host and a few of us able to unmute you, so we'll do the best we can with that as well. Otherwise, I hope everyone has an informative, educational, and dare I say even fun experience over the Splinter. And I'll turn over to Kate for our first actual presentation.
All right. Well, let me set myself a timer here, else I will be the one who speaks over time. Hi, everyone. My name is Kate Meredith, and I'm from Geneva Lake Astrophysics and STEAM. We're the former Yerkes Observatory staff, now on our 3rd year away from the building. And I am a white female. I have a brown hair. It's in a ponytail today. I wear glasses, and I'm here at the Glass Education office. We are going to be looking at sonification, and just before I get started, I want to let you know that some of this was born out of, as Scott said, Sonification World Chat. And there's a lot that I can tell you about that, but the basics are that the purpose of this is to connect various sonification projects that are worldwide. have everyone talking, set standards for inclusivity and equity in this area, and unify and share best practices. There's a lot more information about that on the Slack channel, and you can send information and join, send us your information and join that as well. Also, in the name of accessibility, if there is anyone who is having any issues accessing the presentations or understanding or getting what they need, please let me know in the Slack, and when I'm done presenting, I'll be dealing with those. So thanks a lot on that. And so what is sonification? So in the field of sonification, audification, there are a lot of technical jargons and lingo to be used. And what we want to do today is narrow down where we're going to be focusing into the area of sonification of astronomical data. The Sonification World Chat deals with sonification in all of its forms through all of the sciences, but we're going to have a fairly narrow focus today, and that is going to be we're going to be really focusing on sonifying data. So what sonification for today's discussion is not, is dealing with sounds. So this slide says sonification is not sounds produced in nature. There's some pictures up here about a microphone that's under at the ocean floor, a couple of slides, images showing whales or porpoises, and some of the sound visualizations that come out of the sounds that they make in nature. Also seismic data, which is sound oriented as well. Their recordings, they can be analyzed. We can do all sorts of manipulations with them and then analyze them, but that's not what we're going to be dealing with here. We're not, they can produce data from those types of things, but that is not our focus. We're also not going to be focusing on any kind of sound that's synthesized or generated in terms of that gives information like an emergency weather report alerts, medical alerts, ambulance bleeps, all of those sounds that we encounter every day that give us information. In the sonification world, we refer to those as ear cons or sound icons. That's not one of the subjects of today. But what we are going to be doing is representing data as sound. And we can get data in sound form. We have lots of graphs. We can pie charts, and we can sonify histograms and line graphs, even weather data. We can take data. And so sonification that we're dealing with today is representing sound from data. So it's data dependent, it's systematic transformation of data to sound, and it must be objective and reproducible. This implies that we have an application or an algorithm that can be applied repeatedly with other data sets. And so we want, and for today, we're specifically looking at its application, not across all the sciences, but in terms of astronomy. Okay, let's see. So why use sonification? And there's a number of reasons that this has become very popular. It's very compelling and interesting. And part of that is because the human ear can actually distinguish really small changes in frequency, and we can do it really rapidly. We can process this much faster than we can do visually. And we can detect these very small changes. In addition, when we're thinking about accessibility and why sonification is providing greater access to data and exploration for both sighted and blind or low vision astronomers or students, is because individuals with BVI individuals or blind or visually impaired individuals have life experiences that interpreting information auditorily. And so they have a lot of practice with that. And one of the things we've been able to do is actually document this in terms of MRIs and PET scan studies that show that no matter whether you are born congenitally blind or you have a late life vision change, that over time, in a fairly short order, your brain will actually recruit elements of your visual cortex to map sound information to. And so because there's a great variety of visual acuities across the visual impairment spectrum, this is, and individuals different, even just being right-handed or left-handed changes how that data is processed, that it opens up a lot of really interesting areas for us to look at. Now, it's also, as I think many of you were at Brian Nord's talk yesterday, and I think he really put it quite eloquently. We do these things because they are the right thing to do. When we're developing our projects, which is why we're here today, is to talk about how we coordinate those things. When we have those conversations, when we ask those questions, who's in the room with us? So we need to be sure that from the ground up, we're all talking to each other, and that included in that conversation our main target population, which are people with visual impairments. So I leave you with that as we move forward, and knowing that one of the things that I find most compelling about this work in sonification is that making sure that as we develop that we don't leave anybody behind. So I am going to share my screen again because I just ditched Anita's presentation. So I will be back. Anita, you're going to be up in just a second. I'm going to exit this one and bring yours up. And we will start. And let me see. Hold on. I think I might have shared the wrong screen. Let me try that one more time. Stop 2. And there we go. Okay, next up, out of the Sonification World Chat, there was a survey developed, and what we want to do is hear about some of those results.
Yep, thank you, Kate. Hi, everyone. So I'm Anita Zanella. I'm an astronomer based at INAF in Italy. I'm white female, brown hair, and tonight I'm wearing a red pullover. So I'm very glad to be here today and be able to give you an overview of a survey about sonification projects that have been conducting together with Chris Harrison, Fia Damsta, Kate Meredith, and the team of Sonification World Chat. If you didn't fill in the survey and would like to do so, there is a link at the bottom of this slide that will be pasted as well in the Slack channel. Or you can just email to us later on if you want to have it. So next slide, please. Yeah, so the idea behind this survey is to collect information about ongoing and past sonification projects, to consolidate and share knowledge, to work together towards shared standards and start to define best practices for the future. Also evaluate the efficiency of sonification projects and define together what are the next needed steps to push sonification projects of scientific data forward. So far we collected 20 sonification projects. They are spread all over the world. The majority of them are based in the US, 1 in Canada, 5 of them in Europe, and the other 5 in Australia. Next, please. So the first sonification projects in our survey started in 2016, and many other projects started afterwards, with the bulk of them starting in 2019 and 2020. So I would say that this is really the right time to put together our efforts, start to understand what's the knowledge that has been produced so far, what's the state of sonification, and what are the next needed steps for the community to push it forward. Next one. So we asked the participants of the survey to indicate what's the primary motivation and the purpose of their projects, and we got a variety of answers. So some of them focus on research, others on accessibility, outreach, education, and some of them also art, as they use scientific data as a source of inspiration for artistic creations. Next. And the audiences as well that have been targeted by these projects are very different, from specialized researchers to the general public, students, and even families. So these are mainly multidisciplinary projects that really involved a variety of specialists, some working with sound, specialists in the research field that have been the main focus of the sonification project, people working on visualization, computer engineers, and educators, including outreach experts and parents. So there is a variety of background, people with different background that are working together. Blind and visually impaired are involved in 75% of the projects. They're mainly involved in the testing and evaluation phase. And in some cases, to our knowledge, blind and visually impaired are also the main designers or co-designers of the project itself. These projects use different type of data for sonification. Some of them use 1D data, others sonify bidimensional data sets, some sonify cubes, and others videos. So some of them sonify a specific type of data, whereas others can sonify different kind of data sets. And most of the projects are multisensory in the sense that they don't only include sonification, but also visuals, speech, audio, and possibly haptic elements. So at this point, we can really start to brainstorm about the next steps that are needed. And I would leave the floor to Chris for this last point.
Thanks, Anita. So I'm Chris Harrison. I'm an astronomer at Newcastle University in the UK. I'm a white male and wearing ugly headphones this evening. So as Anita said, one of the parts of the survey was to think about the next steps we should take, and we'll discuss this later in this meeting too. And some things that came up was to continue connecting the different teams from the different projects that previously had mostly worked in isolation, to start thinking about testing, rigorous testing of these projects to make sure that they're useful and they're really fit for purpose, whether it's for BVI accessibility or for sighted users. Increase the level of documentation, including peer-reviewed publications, so we can really disseminate the knowledge that we have and make sure these projects can be used widely, and start working towards some common standards and promoting the use of sonification for research and outreach in general. So, as well as this meeting, we'd like to bring your attention that there's another meeting that's going to be happening later in this year that's been led by me and Anita and Kate, as well as others. This will be happening at the Lorentz Centre in 30th of August and 3rd of September this year. However, we will be having some open call for some remote sessions. The details are to be decided. It depends on how much in-person versus remote possibilities we'll have. But we'd like to just make you aware of this. And if you've got an initial interest in joining whatever sessions we have, you can contact me or Anita about that. And we'll be spreading out more information in the coming weeks and months. So I will also post our contact details in the Slack channel so you can do that. So that wraps this up. Thank you very much. And thanks to Anita for our summary there.
All right. And I think now it is our time to start with our lightning talks. And Clara is going to share her screen. Okay. And first, Allison, you are the first up, I believe.
All right. Hi, everyone. My name is Allison Barilla. I'm at the Center for Astrophysics, Harvard and Smithsonian. I'm really excited to be here to talk about light, sound, and orchestra in 5 minutes. Just want to acknowledge quickly some collaborators. Soleil Hyman is worked with us on this she was a Harvard undergrad. She's now at the University of Arizona as a grad student. Wanda Diaz-Merced, which many of you probably know, was part of this project from the beginning. And Daniel Davis was key in building the first prototype design. I just want to say I'm a white female, glasses, long brown hair, wearing a blue shirt. Next slide, please. So we'll jump into the light sound. These devices are very similar. They're sonification devices that we developed for similar reasons. So this one was developed for solar eclipses to aid as a tool for blind and low vision users. We developed this in 2017. It's a low-cost tool. It costs about $60 to build. It has a high dynamic range light sensor, and Arduino hardware, so that has a microcontroller board that basically converts the light to sound, which can be output either through headphones or a speaker. So one device at an event, attached to a speaker can make the device or can make the event accessible to many more people. It runs on a 9-volt battery. It's about the size of an iPhone. So there's a picture here of it attached to a tripod. It's about the size of a modern iPhone. And it also connects, if you decide to power it through a computer, you can connect it to a computer. So we have that option. And when it's connected to a computer, you can also collect the data. So the data can be collected to be analyzed for future use, or we can plot the data real time. There's very detailed documentation that we have in both English and Spanish, and all the documentation and code is open source. Next slide, please. We'll do a quick sound clip if possible. So this is kind of a sped up version of what you might hear during an eclipse. Hard to hear that, but it goes very low. And then we come out of the eclipse. So this is really fun because you can kind of edit the code once you have it and change the instruments, change the sound profile. As I said, everything's open source. Next slide, please. So in 2017, we had 3 devices. The most recent eclipse in South America, we had over 200. We're really hoping for 2024 to just blow that number out of the water, go all along the light path in Mexico and the US. We developed a 2-day AAS workshop that we did in Hawaii, and we hope to do that again as we start to get back together to learn to build and use these devices. But it really takes collaboration. So I hope if anybody's interested, please reach out and we'll happily talk about how to get these or have a workshop at your institution. As I said, there's plenty of online documentation, and we have some lesson plans you know, to use as outreach programs or education tools as well. Next slide, please. Okay, 2 minutes. Okay, so Orchestar, same idea, same size. We developed this one. It's the same idea, converts light to sound based on color. So this one has an RGB sensor. The original thought is to mount it on a telescope so you can kind of detect variations in the night sky. It's tricky with alignment, working on that, but it definitely works with bright objects currently. But the other cool thing is if you flip it around, there's another sensor. You can turn on an LED and it works with reflected light. So in the picture on the left here, a user is scanning it across a poster and it reflects the light back on you. You can also use it on a t-shirt, anything you're wearing, anything reflective. Next slide, please. There's a quick sound clip. Maybe we'll just do the apple since we're short on time, but this is a stress ball. The apple is red and has a green leaf. So when the sound clip plays, it's like scanning across the apple with that reflected light. It's kind of hard to hear. And I don't know, we might want to move on to the last slide, but yeah, wrap up. So the other thing is just the Earth, so blue and green as you go around. So thinking about what we can do is something that I think we're all trying to do, is creating a resource repository, not only with how to access devices and sonification tools, but also with data. It's, you know, often people are like, how do you start this? How do I teach this? And, you know, having data as an example is key, I think. And then educating the community about these resources. You know, people want to learn how to do this. So workshops, having these kinds of events, social media, all very, very good things. And of course, everything has to be accessible to everybody. I think you're muted, Meredith. Or Kate, sorry.
Clara, you're up next. Thanks so much.
All right, so I'm going to introduce Astronify. This is a project that myself, Jen Kotler, and Scott Fleming at Space Telescope are working on, along with Kate Meredith, who you all already know. So Astronify, whoops, come on. There we go. Astronify is a Python package that sonifies light curves. So we're specifically looking at sonifying data series here. So now I'm going to play an example of a sonified stellar flare. So it basically just maps time to time and flux to pitch. And so the goals of this particular project are to create sonification for scientific analysis, as opposed to the many other reasons you could sonify data. and to increase accessibility in astronomy. So to that end, our target audience is blind and visually impaired scientists and developers at all levels, from undergraduate all the way to professional. But this is very much geared towards scientific analysis. And Astronify itself, it's built in Python. It's an open source Python code base. It's on Read the Docs, astronify.readthedocs.io. The code is on GitHub. It's designed for community-driven development. We're just sort of getting that part started because it's only just come out in beta. So it's only just become stable enough that we can reasonably ask other people to look at our code. You can pip install it if you use Python. It's open for issues and pull requests, so you don't have to be a developer to get involved. We always want feedback, but if you are interested in working on the code base, we are more than happy to have you. And one of the side goals here is to have this be integrated into standard archive workflows. So we planned to add this option to the MAST AstroQuery module, which is a Python module for accessing archival data, including at MAST, as just another option along with all the other ways that you already access your data. But that's also part of why we built it in Python to begin with. Python is very popular in the astronomy community, and so a lot of analysis tools are there. And so having analysis and visualization tools, so having the sonification tool that can be used right alongside the other tools that people already use is where we're coming from on that. And so here's a quick example of what it looks like. So it doesn't take a lot of lines of code. This bit at the top doesn't have anything to do with sonification. This is using the popular Python package lightcurve with a K to access lightcurve data. So we have something to sonify. Then it takes not that many lines of code. We use the Soni series class, which is the class that encompasses data series sonification. We give it the lightcurve. We can set the node duration and spacing, as well as configure a lot of other options. This is very configurable. Then we sonify it. Once we have a sonified lightcurve, then we can play it. And so this is what this test lightcurve sounds like. And so this is probably, unsurprisingly, a heartbeat star. You can hear that womp womp sound. But we could also change around the configurations if we wanted, for example, to look more closely at the small scale variation. So this is why it's configurable. You can't have one general set of sonification parameters for all scientific use cases. So that's a quick introduction, and the 3 action points we came up with for 2021 are to make sonifications a standard part of presentations whenever you're showing a plot, particularly for us, a lightcurve, to make Jupyter Notebook screen reader accessible. Jupyter Notebooks are incredibly popular in the astronomical community, but they're very, very not accessible for screen readers. And so that would be a huge win if there was a way to make Jupyter Notebook screen reader accessible. A lot of existing tutorials and instruction would become more accessible to blind and visually impaired scientists. And then to integrate sonification into existing workflows. So instead of just being something fun that you stick onto the end, have something that really exists within serious scientific analysis workflows.
Excellent, thanks, Clara. And next up, we have Jeff Cookie.
Hi everyone, my name is Jeff Cookie. I'm white male, talking to you from Melbourne, Australia. And I want to introduce you to quickly to our tools Star Sound and Vox Magellan, and a couple others really tools we're working on, explain their current and future directions. This work is done by myself and Gary Foran at Swinburne University, and all of the heavy lifting is done by Jeffrey Hannum at the RMIT University. Next. So I don't have any sounds. I apologize. I didn't think I'd have time, but I'll introduce you to Star Sound first, which is a tool that sonifies 1D text data, ASCII text data, such as light curves, spectra, plots, and things. Shown is a image of the user interface. So these tools are all require no special equipment. They just on your computer or laptop, and it's used for sighted and blind and visually impaired users. This tool has a lot of components to it or parameters that you can set. You have a choice of 128 musical instruments, tone quality, stereo, panning, the speed that you go through it. We found that going through it fast sometimes is wonderful. Tremolo, noise for error arrays, etc. And it can also, importantly, do multiple parameters, such as the data and error at the same time, or different parameters of the data. Can you click next? So on the screen are two images of the different tabs. There are 6 different tabs of the components you can change. One is a visual display showing the data as you play it, and the other one that shown is just some other parameters you can change, the tone quality, etc. Next slide. So the next tool is Vox Magellan. This one works with 2-dimensional arrays, and it's really convenient because when you have any plot, it could be a scatter plot, a histogram, pie chart, whatever, it'll scale that plot to the user's trackpad on their laptop. And therefore you can feel the borders of the plot and you can work your way around on that plot and you can understand scatter plots and etc. And so this has the same applications I mentioned about star sound. It has the stereo and the multiple instrument sounds and overlays of multiple parameters. So you can do this analysis and you can click next. And it does everything from day-to-day scatter plots, pie charts for maybe your financial work or whatever, if you're not an astronomer, to actual data and even collapsed diffuse spectra and even low resolution images. Okay, next. So the last 2 tools I'll say really quickly about is one's called Sophia, which tries to, we're working on trying to understand the morphology and spatial positioning of objects on images. And so if there's an image of a star field here, it's a zoom in of just some stars, and it takes that and applies sound to it. And the sound uses multiple different forms, maybe like as in well, I won't get into, but it's kind of in the cavernous, like you can get the sound of the I can't think of the word right now, but the room you're in, get different sizes, and then also where it is on the image. Can you click next? And finally, we're using independent component analysis to deal with low signal to noise data. So if you have data that has very low signal to noise, you can pick that up by eye or with some machine learning or tools, but the human brain works very well with human hearing to pick up low signal to noise sounds, and it's called the cocktail party effect, and I can discuss that more later. Actually, I can discuss all of these more in detail later. But in short, these tools are aimed, you can click the next slide, these tools are aimed to work with 1D, 2D, and 3D data, even 4D if you're in time, and it's for scientific purposes. We initially designed those to analyze data for some programs that we work on. One of them coordinates over 80 telescopes with multi-wavelength data, and we analyze the data very fast, so we need to analyze that data accurately and quickly, and sonification helps out immensely. But they're also aimed for everyone to do in their everyday life. It's for accessibility to talks, for talk audiences, very powerful in that context, and for citizen science STEM programs. They require no special equipment. Last slide, please. So the 3 points are: 1, to raise awareness for talk accessibility and make all talks accessible and commonplace. That is every talk, business, medical, educational, etc. Point 2 is to develop a fundamental set of sonification standards, and hopefully the BVI community will help with that, what things are intuitive for sonification. And lastly, I think there should be a global award program for universities and institutions to acknowledge and incentivize inclusion efforts. We have the framework for diversity and gender equity. We could use that framework to then promote inclusion. Thank you.
Wow, you did a perfect 5 minutes. So I'm up next. My name again is Kate Meredith, and I am standing in for Josh Hayslip. He is the primary developer on the Afterglow Access accessible software. It's part of the Skynet Robotic Telescope Network suite of materials and tools that are available, that was developed through the University of North Carolina at Chapel Hill. Glass Education, along with a large collaboration, worked with them over the years to increase accessibility to the Skynet network. And one of the issues that we ran into through that was the ability to actually manipulate the data accessibly. So next slide. So for this process, so Afterglow Access was the product of a National Science Foundation grant to rewrite the original Afterglow software, which is an online image processing tool for astronomy and associated with the Skynet network. It is designed to allow research-grade image analysis without the need to download images or software. So it's all done server-side. And so 2016 through 2019, Afterglow Access was redesigned with a focus on implementation and using the user design process to recreate the software in a way that was helpful for blind and visually impaired students and astronomers. Next slide. Some of the things that we were successful at doing had a lot to do with low vision. I'll go quickly over those, but there's a lot more information available about this. What you're seeing on the screen is the Afterglow Access user interface online. It has really solid screen reader accessibility and a lot of different features that allow low vision users to navigate easily through the screen. So we've got the user interface with the library, the image window in the middle, and then display settings I've got a pop-out window that's a little larger, and we've got a lot of different tools which we could give a tour to another time. Next slide. Another area that we focused our user-centered design on, the students worked with astronomers, BVI and sighted students and professionals work together. One of the areas that was very popular was to have a navigation tool or customizable themes that persisted through one session to another. So when you open your Afterglow Access, it adjusts in terms of the color, the weight of the font, and the size of the font, and any combination will work. Next slide. And so toward the end of the project, a sonification tool was developed to sonify fits images, and this one works. I did not set up a file for you to hear. We can do that at another time, but it scans the file from the bottom to the top. It uses piano tones from low tones on the left to high on the right. It scans and the volume is controlled by the brightness of the pixels. You also have the ability using screen keyboard commands to zoom in on any part of this multiple times so that you can investigate areas of interest with greater detail. You can adjust the duration and the number of tones you hear, so you have a lot of control over this. But this is in its early stages. We currently have a new National Science Foundation award proposal in to finish this and do usability testing on this and actually see, is it successful in allowing students to, in our test cases, to do an asteroid light curve, to actually pinpoint an asteroid, photometer the source, and then and interpret the data. Next slide. So according to Josh, these are the things that are most of issue presently in terms of where we should go, is that, skipping over quickly the intended purpose, the audience is college students and high school students, and we want image grade software development and standards for, it uses standardized photometry and astrometry measurements from AstroPi. Next slide. And so if we are looking at the future of this, we develop image sonification algorithms which effectively convey color information in addition to position and intensity. Focus on how well these algorithms work with existing workflows in astronomy, and plan for sonification tools to how they can be collected, organized, and integrated within existing astronomical processing tools and libraries. That's it for me. And next.
Okay, yes, I'm here, Kate.
Okay.
Mine is, yes, let's go. Well, this is, I'm a white woman, brown hair, and the glasses are part of my body because I use it since always. So this is a real work from my student, Joanna Casado. I'm here in the name of her. And next slide, please. It's about what the Sono is. It's a platform based on a user-centered approach. And the purpose is the data analysis and data retrieval, which permits the people with other sensory styles to explore scientific data. It's a multi and general develop between a lot of specialities. Next one. The audience, well, we are thinking in four main things when we think in the audience. First is accessibility to the data, all kind of data, efficiency, flexibility, and of course, we develop the paradigm for training researchers and interested citizen science in general to start using new techniques. The next one, please. The main characteristics are that this software intends to use the sound as a complement of visualization, not to replace it. It's a user-centered design, as I said, an open source and cross-platform, and permit an input of large databases or data sets and a sound synthesis. Well, we aim to eliminate the barriers to access the research and improve the work with different styles of data exploration. Next one, please. The design is modular. You can act in different parts of the software. And on the right, you can see a deployment and a screen deployment. You have all the data at the same screen. That was one of the demands of the users. There is a part with the data, the plot, the sound, and the mathematical, the mathematical functionalities. Next one. Well, here is the Sono Uno in action. I cannot go to the sound. The idea is to show here, I promise to put this presentation available for everyone. The idea is to show that Sono Uno respond very well to the voiceover, for example, the screen readers. So it permits to access to everybody to the data. Next one.
You are currently in the text area.
Other
File, menu, open command option O.
You are hearing the voiceover. You can reproduce discrete data as the image on the left are cosmic rays. You can manage not only the pitch and scan the frequency, but also the time intervals. Please push the first yes, let's go. Okay. Now, yes, you are showing the second one. You can deploy more than one column, more than one data, several data at the same time. The next one. Now, next slide, please. Next slide. We are working right now with a project, international project by the European Union, is Reinforce, and we are preparing the a special experiment on perception with this kind of software. Next one. Next slide, please. Well, the final development is the website. The website, next slide, please, is devoted to show the same interface that Sono Uno. And for that, we use all the web resources to produce a front end and a back end. And next slide, please. We have the same user interface as Sono Uno desktop, but on the website. Next one. Next slide. Well, this is an example of that. I have 30 seconds. So this is an example, yes. The web is available, so we will show all the presentation next time. And the last one, the last slide, is the 3 main points for us. Recognize this kind of exploration as a valid study in data research and in science research, and hence the work of the scientists accepting this kind of new techniques to improve and to access the data with more perspectives. And finally, stimulate the agencies, the funding agencies, to assure that the people with disabilities help the scientists with are not disabled. Thank you.
Excellent. Thank you very much. And our last presentations from Arista Labs.
Hello, everybody. My name is Henry Winter. You'll see that on all the papers, but everybody calls me Trey. I use he, him, and I identify as a white male. My hair color I characterize as non-existent, except for my COVID beard, which is getting longer by the day. And I'm here to tell you about the Eclipse Soundscapes Citizen Science Project. This has grown out of another project. My co-founder of the Arista Lab, Mary Kay Severino, and I are heading up this project for the NASA Science Activation Program. And we have many partners, including the NASA Space Science Education Consortium, National Federation of the Blind, National Center for Accessible Media, and the New York University Tandon School of Engineering working with us on this project. And we have this many people and this many groups working on a project to make a truly accessible project, you cannot do it in isolation. It actually takes a team with a diverse background, including members of the communities that you're trying to serve. And so we're trying to work with as many different groups as possible. Next slide, please. Next slide, please. So in this slide, there is an image of people using the Eclipse Soundscapes mobile application for the 2017 Eclipse. This image is a grid with 9 other images inside of it. Most of these images are of people who are friends and colleagues at the Carroll Center for the Blind, just outside of Boston, Massachusetts and Newton, Massachusetts, using the Eclipse Soundscapes app that we developed in 2017 to experience the eclipse. That project was heavily centered around trying to communicate what was going on in real time so that anybody could use the app. But we focused on people who are blind and low vision early on, and had consultants who were blind and low vision working with us at every step of the way. Not only did we use sonification tools such as our rumble map, which combines sound with something called frequency modulated synthesis to help shake or rumble a mobile device so that you can have the experience of feeling different features of an eclipse. But also too, we hired the National Center, we partnered with the National Center for Accessible Media to provide what's called illustrative description of images. We had audio files, we had text, and we had images. So any way that the information was most accessible to you, we tried to use. But what we realized for this app, and we had very limited time to make it, is that it allowed people to experience and share the eclipse. And now we're trying to broaden that so that everyone can participate in real scientific analysis during an eclipse and participate in science in a real and meaningful way. So what we are now working with NASA on is the Eclipse Soundscape Citizen Science Project. It focuses on what Kate said earlier is not really data sonification. It focuses on this new field of soundscape ecology, and actually is part of the original and extends the work of the original Citizen Science Project, which was done by Wheeler in 1935, of how do eclipses actually affect wildlife. And several ecologists have found that you can actually very accurately monitor life changes and wildlife by using soundscape ecology. So we are building a series of accessible interfaces for existing tools to allow users not only to record these sounds, but to actually also perform the data analysis. And the idea is to bring the bar so that everybody can participate in the project on an equal level. And we are also looking to work with more people with their sonification techniques and how we can use different tools and techniques, not just the ones that we're developing, but the ones that already exist, into our UX, UI experiences so that everybody can actually manipulate the data in a way that makes sense to them. And as we've always found in these things, when we design for accessibility, we make a better, more engaging experience for everyone involved, because it turns out that the more senses you use in order to understand something, the deeper that learning actually is. Okay, and next slide, please. And being a citizen science project, we have an audience of basically informal learners. We are trying not to narrow our audience too much, but we do have a focus on blind and low vision learners. And again, we found that if we design for those learners first, it makes it easier to design for all learners. But everybody who has an interest in science, we want them to be able to participate and remove any barriers possible. And again, like I said, we want them to engage in the scientific process from the beginning, from taking data all the way to publishing a final paper. Next slide, please. So I'm, as all of us are, we're limited for time. I do have 3 points I wanted to make. And one is I am very appreciative of Kate and everybody involved in the World Sonification chat. It helps for the closer connection of different groups like this. And I am trying to make it so that we can connect in ways that are outside of meetings. I'm going to reinforce what I've said before. I think we should encourage funding agencies to help pay for these opportunities and for collaborative work. I think that we will start making more real progress once we can actually get this into the grant program. And I have found that people at NSF and NASA are open to this and want more community input for it. And lastly, I want to make sure that our community isn't insular. There are a lot of great projects out there, and they're usually to solve a specific problem for a specific group. But I want to make sure that we reach out to scientists who may have never thought of sonification before and let them know about the products and things that we're developing so that they can integrate sonification and other accessibility techniques into their existing tools. And I apologize for going a little over.
It's okay. We've done really well as a group. We're only 2 minutes total over, and it is time to move on to the important area of the discussion.
Yeah, thanks everyone for those amazing presentations and for sticking on time.
And we can direct you to resources. A lot of these presentations have been recorded and are stored with the Sonification World Chat.
And the PowerPoint with all of the presentations, all of the links, and all of the slide descriptions, I linked that in the Slack group.
Oh, great.
Okay, is it my turn to take over?
It is your turn.
Okay, so hello everyone. My name is Jen Kotler, and I feel like I'm sharing the wrong screen. I'm sharing Slack, aren't I?
No, you're not.
Oh, I wasn't. Okay,
You're good.
I was sharing the right screen. Well, let me
Yeah,
do
I
that
saw
again.
the correct screen.
Okay. Okay, so we're going to be moving to a workshop section of that I'm hoping will be very interactive. This would be best done in person, but unfortunately we'll have to adapt to being remote. But for you, in order for you all to participate, I need to make sure you have access to the Slack channel. So I know some of you have been active in the Slack channel, but I just want to make sure everyone is able to participate. Scott, would you mind reminding everyone how to get to the channel?
Yeah, sure. So if you're in the Slack app, at the very, very top of the app is a search bar, and you can just type in the first words of our meeting, Splinter _ increasing, and you should see the full long title show up, and you can join the Slack channel from there. And then real quick for the speakers, since you were probably getting ready to talk or talking, there have been a couple of good, really interesting questions that have been asked by some of our audience members. So if you can hop into the Slack chat and see if you have any further responses, that would be a good activity to do either now or later in the meeting as well.
And just to mention to Jen, whenever you can, zoom in, those the stickies do come up small.
Okay, great. So to give you, okay, so we have a half hour, so I'm just going to jump right into it. So there's going to be multiple steps to this workshop. And the first step is going to be a brainstorm. We're going to have 7 minutes only, and I will put on a timer. And we'll be brainstorming what the most impactful actions can we take to make sonification ubiquitous in astronomy. And so I want you, when the brainstorming starts, start thinking of ideas and write one discrete idea, one actionable idea per chat message, and just put that in the Slack. And so then I'm going to be copying each of those ideas onto these Post-it notes. You could see the 3 ideas from each of the meetings, each of the presentations by our presenters I've already made Post-it notes for. So I'm going to be putting lots and lots of Post-it notes up on the screen for this first section of the workshop, okay? So I'm going to get the timer started, 7 minutes, start. Okay, so what are the most impactful actions that we can take to make sonification ubiquitous in astronomy?
And specifically in the next year or so. So we're looking for sort of concrete steps we can take, small moves, as the movie Contact says. And there's no wrong answers. So just, you know, like I said, this is a creative experience. shout them out, I guess, in the Slack channel politely. And Jen, you have access to the Slack, so you can directly type and
Yep.
Slack at the same time. Okay.
I will be copying.
Really multitasking you here.
I'm going to be multitasking. Let's see how good I can use my computer. Oh, come on.
Is it too distracting to chat about some of the ideas while you type, Jen? I'll be quiet if it is.
Yeah, let's because ideas are still coming in, so
Yeah,
let's
okay.
focus entirely on brainstorming. So everyone, 2-minute warning.
Great stuff.
Yeah, and I think we'll also make sure we post a summary of these to this channel as well, so that's all in one spot. Not today, obviously, but later when we have a catch our breaths, we'll maybe we can take these post-its and make a nice PDF so everyone can have it to take home with them too. These are all awesome ideas. I was worried y'all wouldn't be saying anything, and y'all are just fountains of ideas, which is exactly what we wanted. So this is awesome.
But this is good to see that each time more people ask for more activities on this kind of approach to the data, more meetings or exhibitions or workshops or whatever.
So
and,
1 minute warning for any more ideas.
Yeah. And this is part of this activity to join people, to know how it is possible to analyze data using another ways to approach. So
Yep.
If we act, more people will join us.
And I think, we'll talk about it later. I don't want to interrupt the brainstorming.
Yeah, sorry.
No, it's okay.
Already received some requests to join the Sonification World Chat, so
Excellent.
that's in there as well.
Yeah, the meeting doesn't end in half an hour. All the speakers, I think, are part of Sonification World Chat, and we meet every month through Zoom, roughly every month. So join us for that too.
Okay, so we have reached the end of the 7 minutes. I see some people are typing, so I'm just, there's 2 left. So I will copy those last ones in, and then we're going to move to the next activity. This next activity is going to be a little bit of a pain to do remotely. So I think the people who with voice can contribute, and then anyone else can make comments in the chat. But basically now we're going to take all these ideas. I'm going to copy them. And for the next 7 minutes, we're going to do something called affinity clustering. Affinity clustering is when we look through all of the ideas and we group them by ones that are similar to each other. Because I think as I was going through, I was definitely seeing some ideas that are related. So we're going to start grouping these because some of these ideas are repeated. So I'm going to go and read through each one and we'll start grouping them. Okay, so the first one is make sonifications a standard part of presentations.
Mm-hmm.
Make Jupyter notebooks screen reader accessible. So, okay, already I'm just gonna start like labeling some of these. Oh, let me start my timer again so we don't go over 7 minutes. Okay, so started. So make sonifications. So this is public outreach perhaps, or communication. So if other things fall under that category, we can call it that. This is tech accessibility. Okay, integrate sonification into existing workflows.
Mm-hmm.
I feel like that falls under science research, or like research perhaps. Okay. Develop a fundamental set of sonification standards. For example, assign tones for basic symbol shapes and pitch for plot location. Okay, I'll put that out on its own. Initiate a global award program for universities and institutions to acknowledge and incentivize inclusion efforts. Create repository with resources and community data. So I'm going to put that under, already having some trouble grouping these. I'll put that off on its own again. Recognize
maybe communication.
Under communication, okay. Recognize multisensorial exploration as a valid study of the data. So I feel like that's under research. Enhance the work of the scientists accepting and adopting the data exploration styles, more perspectives and experience.
I'm wondering if advocacy, does advocacy sound like a category we're coming up with?
Yeah, definitely.
And maybe the one above it is funding, or
I spelled that really wrong, sorry. Okay, funding.
Or resources or something.
Hi, Paul.
Okay.
closer connections between groups outside of meetings. So I'm going to say that's communication. Or maybe network, perhaps. Actually, okay.
Given how many we have, maybe we could try to start off with bigger,
Yeah, you're right.
more comprehensive ones, and yeah.
Definitely. This is a little overwhelming doing it this way.
We might
Okay.
have to continue this offline too at some point, but
Stimulate funding agencies to ensure proposals are funded. Okay, so that goes under funding.
yep.
Continue to raise awareness for talk accessibility while investing time and funding for talk accessibility. I feel like that is communication. Educate the community of these resources through workshops and social media. I think that's
Advocacy.
or advocacy. Okay.
Yeah.
Increase focus on how well a sonification algorithm fits within existing workflows. I think that's research. Encouraging funding sources for paid opportunities. I think that's funding resources. Make sure that the community is not just for creators of sonification, but also for scientists and other users. Okay, that's research. Make it all accessible. That's tech accessibility. Development of image sonification algorithms which effectively convey color. I feel like that's new tech or something.
Yeah, research or tech.
Research. Okay, just gonna add another one that's like tech that's related to research. Okay, I'm already halfway through the time. Okay, plan for how sonification tools can be collected, organized within existing libraries. I feel like that is kind of related to some of these. Recognize multisensorial exploration as a valid study.
This just repeated.
What do you think that one is?
I think you have just this line before.
Okay, sorry, I can't really hear what you're saying. Publicize sonification in the press and meetings and publications. I think that's similar to some of these communication. Okay, building a resource with best practices for making talks. Okay, yeah, great. Also communication. A white paper walking through analysis of specific tools. So yeah, this is one. Well, okay, so I guess that's research. Make NSF and NASA aware of the importance of sonification and best practices. Funding resource, I think. Rigorous research to prove that sonification is effective, efficient. So okay, there's like a type of research like viability research, and I saw a bunch of them fall under that. So there's probably a better word than viability.
And you know what, Jen, real quick, I'm going to recommend we do the polling offline. We don't need to do it in person. So let's take our time and do the affinity clustering, and maybe we can just do the polling, set them up and let people vote later in the week. We don't have to do it all right now.
That's
right. Because we're going to do Slack polling. We don't need to do it right now. We can spend more time having this because this is sort of fruitful, I think. If that's okay with you as a suggestion.
Yeah. I had another idea also for getting some feedback on these because I noticed people were thumbs upping ideas in Slack already. So we might be able to just like copy an idea that seems popular and see where they're getting their thumbs up, or like go through the Slack that's already there. Okay. Implementation of sonification tools in the K through 12 undergrad classrooms. So I think that's education. Emphasize the discovery potential to augment visually based research. I think that is research. Include sonified data and published articles online in addition to figures.
That's sort of what I call best practices or better practices.
Yes.
I don't know if we have one yet, but it's sort of along the lines of making sure when you give a talk, you always put a sound in there as well, not just your figure, and put the sound behind the data in publications and stuff like that is sort of my vision for some of those things.
Okay, I'm gonna add.
There are some documents on this, on the best practices. The problem is not all the people follow the recommendations.
So I feel like this, like now makes sonification the standard part of presentations, and some of these other things fall under that.
Yeah.
Sonification press meetings and publications. I feel like maybe that's advocacy. Okay, so let's go continue. Make sure journals allow you to publish audio along with scientific results. So
Advocacy?
advocacy. I poorly spelled advocacy. Tap the enormous time domain photometric databases, ZTF, ASAS-SN, AAVSO, VRO, for sonifiable light curve data. So
That's research. Yeah. Sort of like a mine of data to be able to apply sonification to. Yeah.
highlight sonified data in press releases and public interfacing products. Maybe communicate. We have a few things about press releases, I think. Like, yeah, there was this thing about journals, make sure journals allow you. Okay. Collaborate with big surveys like STSS and have them include sonification in their data exploration page. Yeah, I think that's really good. We have similar potential at MAST.
And in fact, MAST is going to be the home for STSS very soon with STSS 5. So we could even help with that.
I wonder if there should be something like workflow, like as part of research. Not exactly sure, but it's kind of related to research. Okay. Interact with Astro 2020 State of the Profession write-up and ask for them to mention sonification funding opportunities. So I will call that funding resources. Have a AAS plenary speaker at the next winter meeting who uses sonification during their talk. I think it's funny, it's both advocacy and better practices. But
yeah, it's kind of both, but it's like a oh, interesting. Okay, I was going to put it under like a high profile best practice where it's like, oh, so-and-so did it, so I should too situation, but it could be either. Maybe just copy and, are we allowed to copy and paste and put it in two?
Sure.
Okay, let's do that.
We can do whatever we want. Conduct rigorous testing and evaluation. So, okay, yeah, this is where like the viability, I feel like there's a whole bunch of these about testing sonification. Similarly, begin systematic studies of the ability of sonifications to communicate data accurately. That also falls under there. Begin systematic studies of the ability of oh yeah, I copied that twice. Okay, systematic studies of how best to sonify different kinds of data, like varying pitch, volume, timbre, etc. Also falls under maybe like research into sonification itself. Does anyone have a better label for this?
Optimizing sonification? I don't know.
Okay. Yeah, it's kind of like usability testing, but it's study
Also,
learning.
yeah.
Oh, yeah, sorry.
I was going to say, there's also like validation verification. It's sort of like regression testing of software, but we're sort of regression testing our sounds in some sense.
But doesn't that mean you need to know what you want your outcome to be?
It does, yeah. You need to have standards, which is related to one of the other main categories, right? And also changes based on type of data and why you want to sonify it. So there might be a wide collection of standards.
So, okay, let's see. Study learning outcomes and efficacy of tactile versus sonification are both together. That's this one. Have an exhibition booth in the next meeting that brings together access and information for all the diverse sonified methodologies and systems. It sounds like maybe communication / advocacy. I feel like communication is partially outreach.
Agreed.
Yeah, so like for instance, continue to raise awareness for, yeah. Okay, 2 more, and then maybe we'll have time to vote a little bit. Get a talented musician at the next open mic night to play popular observations on piano, like Beetlejuice variability and C major. That
sounds like a great project for someone like System Sounds to look into.
So that seems like outreach.
Yeah.
Matthew Rousseau is doing some amazing things with that kind of stuff.
Yep.
Have Sonification World Chat representative create a TED Talk on YouTube. Also, I think outreach or advocacy, maybe. Okay, cool. So now we've clustered all of these. And so here's our general categories: outreach, communication, tech accessibility, research, workflow, within science workflows, advocacy, funding resources, tech, testing viability optimization of sonification. So testing sonification, basically. Better practices, I think, for accessibility.
What's the orphan in the middle there? Can't quite see it.
Recognize multi-sensory exploration as valid study of the data.
Advocacy.
Advocacy, okay. Okay, so now we have these grouped into these different concepts. When does this end again?
We have till 20 minutes too.
So
Okay.
we have about
10 minutes.
10 and change.
Okay, so what I would like is, instead of doing any polls, any new polls, since you all have access to the Slack, and some of you have been like using the emojis, I've noticed, to show like smiley face or clapping or hearts for different ideas. So I would like it if you can scroll through and find an idea that you like, your favorite idea of everything you've heard today, and put a plus emoji on it. Because I don't want it to be confused. Let's see, what should we put on it? I think a plus should be an emoji we can do. Let me try.
Hey, Jen, would you mind sharing your Slack screen in case people don't know how to use emojis in Slack?
Absolutely.
If they're not familiar?
Okay. So.
It is 2020. We're using emojis to do science.
Yeah. Okay. So I'm going to go. So I'm scrolling back, and so let's see. Okay. So it basically starts here. So publicize sonification in the press, meetings, and publications. So let's say that's the one, my favorite one I've heard this entire time. I press this little emoji button, and I could search for the word plus. And so we're looking for this black cross plus, and I click it. And so now this one has my vote. So only vote for one, only vote for one. Your very favorite. I'm making you pick, I'm sorry. So vote for the thing you think is most important. And so you can start that now. And then we're trying to come up with what we think the 3 most important ideas that we want to make action on this year.
And do we want to do that right now, you're saying?
Well,
or
I want to
by the end of the meeting, or the week, I mean. What's the goal?
Well, I think let's do it now. Have everyone
Okay.
vote on their favorite. Okay, but I might not be able to figure out what the ones that are getting the most votes are by the
There's
end.
also a bit of a problem where the seated questions are not in chat yet because they probably didn't, the presenters didn't put their ideas in the chat necessarily, right?
Oh, but you're so right, Scott. I'm sorry.
That's
I
okay.
overlooked that.
That's okay. I mean, well, they voted for them, I guess, by putting them on their slides.
I'm wondering if someone could do a shout out for their favorite. If there's somebody wants to do a shout out, a verbal shout out for their favorite, and then we can put it back into the chat with some sort of indicator that we're starting over, and then we can see if would that work. Jen, I'm sorry if I'm messing.
No, what do you mean a verbal shout out?
Like just actually unmute, and I think people can. I'll unmute all. We can just do a free for all.
Well,
Okay.
I wouldn't let
do
people unmute themselves because they might have home situations
Oh,
that they
that's
don't
true.
want. But there's only 30 of us. It's not impossible to make this work like a normal meeting. So I
Yeah,
think that's
and we can
probably
just
doable.
start over again, and then sort of like put a starting here. No one puts any other chats in the Slack for next 7 minutes, and we try and get our favorites on the list.
Okay, and the ones that I see have multiple pluses, I'm going to just start copying in as well because people
Okay.
voted. So
Would that you want to try that?
yeah, let's try that. Unmute
Okay.
and talk about your favorite.
Okay. And if you can, I'm watching for the because you may
And
end up.
we're only allowed to vote once forever.
Yeah, well, I mean, we could talk about this in the future, but for
Yeah.
now.
I mean, we're doing this on the fly, right? So
Yeah.
Um,
It's hard to decide what your favorite is, isn't it?
Yeah, so anyone want to make a shout out for their favorite?
I have an idea, but I want to let someone else have a chance to start.
I came in late, but I already had a thought on this.
Yes.
Please, go ahead.
Okay, so my thought is anything that, and I haven't been able to pull it out of the chat, so help me find it. Anything that demonstrates that we can actually use sound to make scientific sound analysis of data to make scientific conclusions is going to be the most impactful, because that's the core thing that we do as scientists is science.
That's already been done with the sonification of solar data, where they found new relationships between the iron lines in the sun from sonification.
So maybe that as an outreach component, doing either new things or doing, maybe that's the action item. The action item is find out gather all of the data, all of the proofs, and see if we can expand on that.
Well, and I think that idea was like suggested in a whole bunch of different ways. So I think that's a really good one. So by the way, there was actually only 5, including that, there's only 5 that people had plus voted. And I don't know if that means anything, but these are the ones that came to the top of the pile so far. So building a resource with best practices for making talks accessible for BVI individuals. Make sure journals allow you to publish audio along with science results. Include sonified data and publish articles online. So these are actually very related. Begin systematic studies of the ability of sonification to communicate data accurately. Oh, and actually, these 2 are the same. So right now we actually have 3 ideas, but I'm not convinced that they're the 3 most important ones. But these do seem pretty good.
I think one that didn't get mentioned, but it got brought up a lot, is making like either having a high impact talk or press. As soon as you get this out to the public and public gets excited, whether it's like the community or scientists, and they see how impactful it could be, I think people start talking about it and they want to do it too.
Yeah,
So
that was the TED Talk thing, and there's also a couple under advocacy that sound like they roll in under that.
It would be great to create a citizen science project with the whole citizen science realm of asking people to sonify data, because I think there are amazing talents and skills that are in the community that they could bring to it and really publicize it.
There is a project to sonify for the Zooniverse, and they were going to present today and could not make it, and none of us could cover that particular talk. So we, yes, that is a thing.
I think we could probably advertise it though, right, Kate? So it's called Transient Zoo, and it's being led in part by a grad student named Locke Patton at Harvard. I imagine Allison might know that a little bit too, because you're also at CFA, right? But yeah, that's cool. I don't think they're out yet, but I've seen some early demos, and I think they're looking to do citizen science with sound of supernovae and transients, which would be really cool, I think. But it's a great idea. We need more of it. I mean, Planet Zoo is fantastic for the visual, and we should have 5 or 6 of these things ideally, right, with sound too.
I might miss this, but is there some universal standard for like sonifying data? So I'm like, maybe I'm just not aware of it, but when we sonify data, like if you publish something behind a figure, shouldn't we have like some sort of consistency in what we use? Like sort of creating that standard, I guess, is pretty important.
Yes,
it's a hot topic amongst the sonification world chat, actually.
Yeah, it's a big piece of where the sonification world chat's been talking about for the last few months, is that that's really important to start standardizing. That brings into the whole issue of testing and verification and bringing in the BVI community to comment and to input. And so it's best practices is big.
There are actually, just to appreciate that the field of sonification is a huge thing, like at MIT and Georgia Tech and Wisconsin Tech, that it's a huge field, and data sonification. I mean, you can go do a PhD in it if you want, or a master's in sonification and data sonification. So it's a huge field.
Yeah, it really is. Go ahead, Jen.
I'm wondering, so we have 4 minutes. I'm wondering if we should consider these to be some of the top items and perhaps put them back in the chat and have people vote on their own time, or if we should ask people to like continue coming up with ideas, or I don't know, like I'm just wondering what we should.
Well, definitely come up with ideas, but maybe we have plenty. So maybe for the purposes of our take home, I mean, the ultimate take home is going to be all these ideas that I think Jen and I can work together to get into a PDF and give to everyone for take home at on Friday. So keep giving us those ideas tomorrow and Thursday too in the chat. But maybe we'll call it for the purposes of coming up with these 3 things, and we'll do the voting either now or tomorrow as well, if you want, Jen, however you want to do that. If that sounds good.
And just because you vote doesn't mean you can't pop that thread out and start commenting on that thread.
Yeah.
Add detail to that. I'm looking forward to adding this to the Sonification World Chat agenda on the 27th.
Mm-hmm. Yeah, definitely leave comments on ideas that you see to like help flesh them out and make them more specific or similar ideas. This was really great. So apologies for any lack of clarity or awkwardness due to being online, but I really appreciate how many people still participated over Slack, and I hope you had some fun. And remember, even if these ideas don't end up being what we choose as the top 3, if you see an idea and you're like, oh, I can work on that, this is something I can achieve personally, well then you should do that in this next year and create your own resolution to do that yourself, because this is how the work's going to get done. We're all gonna chip away at these different ideas. So thank you, and now I will stop speaking.
Thank you very much.
Yeah, and like I said, please continue to use the Splinter Slack channel the rest of the week. Also, again, if you want to find out more information about any of the projects and don't know who to ask, at least personally, you feel free to DM me as well on Slack anytime this week. Get a hold of me on Twitter or on my email, and we'll hook you up with networking and collaborations. And also remember about the meeting that Chris and Anita are running in the Netherlands, whether it's in person or remote or both. It's going to be an amazing actual multi-day workshop, not just an hour and a half, a multi-day workshop focusing on sonification. So I encourage you all to, if you're interested, to reach out to them as well and express your interest. So that's going to be really amazing in September. Anything else you want to add, Kate? Oh, go ahead, Clara.
If you want to hear more about Astronify, there will be 2 demos out of the MAST booth. Jen, do you have those times on the top of your head?
Yeah,
or
so
you can just come by. One's tomorrow.
A webinar on tomorrow afternoon. I'm opening up my calendar right now, and then the other one is Thursday afternoon. But
and they've also done some really great talks on the Space Telescope Science Institute Public Talks YouTube channel.
Yeah, so our the talk is at from 2 to 2:30 on Wednesday, and the demo, which is actually just a usability test where you get to listen to some of the sonification examples and answer science questions, would be really helpful for us. That is from 4:10 to 4:40 in the STScI booth Zoom room.
And wow, something that's going to be a lot easier to do on Zoom than it would be in an exhibit hall.
Yes.
Yep, so I think we're out of time. Thank you all for your attention. Special thanks to our friends in different time zones for sticking with us. And yeah, let's continue the conversation after today and keep making networks and keep making good progress in promoting this.
Thank you, Scott, and thank you, Kate, and everyone.
Thank you.
Yeah.
Thank you
everyone.
all. Bye.
Have a nice rest of your
Thank you for everybody for setting this up.
Nice day. Bye-bye.
Bye.